All right, section 4.2, the unit circle. Today we're going to create and apply the equations for a circle and then develop a way of using symmetry and patterns to locate points along the unit circle. So developing an equation for any circle. So if we were to consider this circle on a coordinate grid, thinking about rotating around, we talk about this terminal arm and this initial arm. So I'm going to start from my initial arm, which is at 0 degrees. And if I rotate in this direction over time, it's going to create a circle. So if I were to think about this terminal arm at any point on this circle, doesn't matter, it necessarily had to be in this first quadrant. If we were to talk about this terminal arm as in relationship to the circle, would represent the radius of the circle. And then if we were to talk at this point in terms of our coordinate grid, this point would represent x comma y. So drawing our right angle triangle, this distance here would represent x, this distance here would represent y. So if we wanted to solve any one of these unknown sides, we could simply use our Pythagoras theorem, x squared plus y squared is equal to r squared, where x and y is any point on the circle and r would represent the radius of the circle. So this just represents the equation of any circle with the center of the circle at the origin, 0, 0. So as soon as that center starts to shift, it's going to change, but we really don't get into working with complex circle equations. We always work with circle equations that have a center at 0, 0. So for example, what is the equation of a radius 3? Fairly straightforward. Here's the equation of our circle, x squared plus y squared. These values are always changing. However, my radius of this particular circle will always be 3, so 3 squared. So the equation of my circle would be x squared plus y squared is equal to 9. Okay. All right, so what's special about the unit circle? Well, the unit circle specifically will always have a radius of 1. Therefore, the equation of a unit circle will always be x squared plus y squared is equal to 1. All right, so most of our questions that we're going to work are relating specifically to the unit circle. So for example, it says determine a point on the unit circle with an x coordinate of 1/2. So if I were to consider my x coordinate, so remember this unit circle, the radius of this circle is always going to be 1. An x value of 1. If I were to sketch this, so this is 1/2 comma something. Determine the point on the unit circle. Well, our x coordinate is 1/2. That means we need to determine our y coordinate. If I were to draw my right angle triangle, I know this distance would be 1/2. I know my radius is 1, and I'm simply solving for my y value. So 1 squared minus 1/2 squared is going to equate to y squared. 1 minus 1/4, this equates to 3/4. Therefore, this should be root 3 over 2 is my y value. Okay. Well, we also have to consider, well, I could have drawn this point in quadrant 1, but I also could have drawn this point in quadrant 4, because in quadrant 4, my x value would also include a positive x, but a negative y. So technically in front of this y value, because we took the square root of this expression, this should be plus or minus root 3 over 2. All right, question B, a unit circle with a y value of negative 1 over root 2 in quadrant 3. So this is specifically telling you, so in this case there will only be one answer. So if I were to sketch this point in quadrant 3. The y coordinate is a negative 1 over root 2, and I'm solving for x here. So this would be a negative 1 over root 2 is our y value. Our x value is here, and again we're working on the, that tells me my radius has to be 1. So I'm going to go 1 squared minus a negative 1 over root 2 squared is equal to x squared. Well, technically this would be 1 minus 1/2. It's 1/2. So my x coordinate should be a 1 over root 2. But because I am working in this third quadrant, this x value actually needs to be a negative. Okay. Okay, so the next thing we're going to do is we're going to develop the entire unit circle using exact value in the cast rule. Okay, so thinking about this angle at 45 degrees. So we're going to develop the entire unit circle, so all the multiples of 45 degrees. So I'm going to draw a 45-degree angle here. And if 45 degrees and I were to draw my triangle here, technically this will also be 45 degrees. Because we're working on the unit circle, we know the radius has to be 1. And so technically this would be my x value and my y value. We want to develop this exact value, these exact points. Okay, this represents x, this represents y, but technically this is an isosceles triangle where x and y are going to be equivalent because the 45 degrees are equivalent. So using Pythagoras, I know x and y are technically the same, so instead of using x and y, I'm going to use 2 x's, or you could use 2 y's. Add my x's together, divide by 2, take the square root, and I get 1 over root 2. So technically, because x and y are equivalent at 45 degrees, my x coordinate and my y coordinate should be 1 over root 2. Okay, so we are going to, as we rotate around this circle, this exact same ratio of 45 degree with a reference angle of 45 degrees in this quadrant is going to be the same. So these quadrants are going to be the same. The only thing that should be different is that now be negative, and my y value should now be positive. So this is at a reference angle of 135 degrees, or 3 pi over 4. So this was 45 degrees, or pi over 4. If I rotate again another reference angle of 45 degrees, I get to the angle of 225, or 5 pi over 4. And this, again, point should be the same except for both x and y should be negative. So that's this point. And then finally, if I rotate to this point here, we get an angle of 315 degrees, or 7 pi over 4. And this point should now be a positive root 1 over root 2 is my x coordinate, and a negative 1 over root 2 is my y coordinate. Okay, so all of my reference angles and multiples of 45 degrees are all related to each other, except for technically, depending on which quadrant it's in is going to depend on whether those values are negative or positive. Okay. All right, so this is all the 45 degree reference angles. Now let's do the 30 degree reference angles. So what I'm going to do is I'm going to draw against first quadrant. This angle is 30 degrees, or pi over 6. Okay. So instead, what I'm going to do, again, I know my radius is 1. Here, x and y are definitely not going to be the same. They're going to be obviously slightly different. So what I'm going to create is I'm going to create a second triangle, the mirror image of this underneath it. And so when I do that, what I've created is an isosceles triangle here. or sorry, not isosceles, equilateral. So the radius here would be 1, this would be 1. That means this distance here would also be 1. So that tells me if this is the mirror image of this, then our y value would have to be half of 1, which is 1/2. So right away I can figure out that my y value is 1/2. I am now going to find my x value by using Pythagoras. And taking the square root. My x coordinate is going to be a √3/2. All right, so now we're going to create these mirror images along or rotate around our unit circle. So I can create this exact same point here at 150 degrees or 5 pi over 6 radians. And that point would be √3/2, except my x value would be negative and a positive 1/2. Rotate once more into my third quadrant. This angle here is 210 degrees or 7 pi over 6. And this point here again would be a negative √3/2, negative 1/2. And then we're going to rotate one more time over here at 330 degrees or 11 pi over 6. And this gives me √3/2 and a negative 1/2. So as you can see, all of these ratios are the exact same, except for, depending on which quadrant we're working on, whether those values are negative or positive. Okay, and the angles that relate to reference angles of 30 degrees would be 30, 150, 210, and 330. All right, moving on to our 60-degree angles now. So I'm going to do slightly the same thing as I did with my 30-degree angle. So here's my reference angle of 60. Okay, but rather than, I know we always draw this triangle this way, but I am, for this one time only, I am going to triangle this way. Again, to create its mirror image on this side. So I again can create this equilateral triangle. Because what happens is that this angle in here is 30, another 30, so that's 60. This up here would be 60, 60, so we have an equilateral triangle. So this distance I know is going. So technically this horizontal distance now, which would be equivalent to this horizontal distance, is going to be half of this distance of 1. So this would be 1/2. And again, using Pythagoras, I can use solve for my y value, which essentially is going to be the same as our 30-degree angle. And I get a y value of √3/2. So again, all of these points are going to be equivalent except for our negatives and positive. So in this second quadrant, this is going to be 120 degrees or 2 pi over 3, which would be now negative √3/2. And then this angle down here would be 240 degrees and 4 pi over 3, which would now our x and y value would be both negative. And then finally this last quadrant here would be 300 degrees or 5 pi over 3. This point is going to be 1/2 comma negative √3/2. All right, so this basically sums up the unit circle. We didn't do the 0, 90, 180, 270, or 360 degrees, but we will add those in once we get to actually talk about the unit circle. So thinking about all of these angles, right, and these points relate to these reference angles and or angles in standard position. Example 3, it asks, what is the location of 1/2 comma negative root 3 over 2? Well, I'm literally going to look this up. Here we go. 1/2 negative root 3 over 2. The location would either be 300 degrees in degrees or 5 pi over 3 radians. Okay, what is the location of negative 1 comma 0? Well, this is my x value. This is my y value. So thinking about this unit circle, when is x negative 1? Okay, so negative 1 would be this point here, right? Because this represents the radius. So now it's giving us the radius of our unit circle. So here at negative 1, and my y value would be 0. The angle in standard position would be 180 degrees, or pi radians. Okay, so what this brings us to is completing the entire unit circle, and basically for most of us you are going to have to memorize the units to easily write it out to be able to reference it on an exam. So we're going to start by writing out all the angles all the way around from 0 to 360. We're going to do the same thing in radians, and then we will start by plotting our points of each coordinate point around the unit circle. So obviously this point here is 0 degrees, 360, or 2 pi radians. Here we have 30 degrees, or pi over 6 radians. Okay, so maybe I'll talk about and we'll come back and do radians. So here's 0, 30, this would be 45 degrees, 60 degrees, 90 degrees, 120, 135 degrees, 150, 180, 210, 225, 240, 270, sorry, I'm just going to move these closer to my 240 degrees, 270, 300, 315, and 330. Okay, now I'm going to show you just a trick on how to get all of your radian measure. Okay, so if you know this first one, which is pi over 6, which you kind of have to know, I'm going to do all of my 30 degrees, every 30 angle, which really includes my 60 degree angles, and then I'm going to do the same thing with my 45 degree angles. So this would be 1 pi over 6, and then you're literally going to add 1 pi over 6 each rotation. So this would be 2 pi over 6. Eventually we're going to 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and this would be 12 pi over 6, which is 2 pi. So now I'm going to go and simplify all my 60 and 90 degree measures. Well, 2 pi over 6 will simplify to pi over 3, 3 pi over 6 over 2, 4 pi over 6 simplifies to 2 pi over 3, 6 pi over 6 simplifies to pi, 8 pi over 6 simplifies to 4 pi over 3, 9 over 6 simplifies to 3 over 2, and 10 over 6 simplifies to 5 over 3. Alright, so there's all of our pi's, or all of our 30 degree rotations. Now I'm going to do the same thing with my 45 degree angle. Well, if 90 is half a pi, then 45 has to be half of that, which is a quarter pi. And I'm going to do the same thing. I'm going to just count quarters now at every 45 rotations. So this is 1/4 pi. This would be 2/4 pi, which is already half. This would be 3/4 pi, or 3 pi over 4. This would be 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4. So that is just a quick reference on how to get all of those points, or all of those rotation angles. Okay. Okay, so now we want to include all of these points. Okay, so another easy way to remember how to get these values is each of these has a x and a y value. So I'm just going to do my first coordinate, and all of my other coordinates are going to follow suit with this. This first point would be 1, 0, right? Because the radius of this is 1, which is x, and our y value would be 0. At 90 degrees, this is going to be 0, 1. At 180, this would be negative 1, 0, and at 270 would be 0, negative 1. All right, so an easy way to remember these values, okay? If you start on the outside, all of these fractions are going to be over 2. You simply count the numbers 1, 2, 3, 1, 3, and then you're going to do the same thing back down here. 1, 2, 3, and then you're going to take the square root of each of these values. Well, the square root of 1 is 1, the square root of 2 is root 2, the square root of 3 is root 3, the square root of 1 is 1, this would be root 2, this would be root 3. Done. There's all of your ratios. And then all of these points are, what is this? These, except for negatives. So in this quadrant, 120 is going to mimic this. So 1 over 2, but all of my x's in this quadrant should be negative. Negative root 2 over 2, root 2 over 2, negative root 3 over 2, 1/2. This again is going to mimic, so this is relates to my 30-degree angle, 45 and 6, except here both x and y should be negative. So negative root 3 over 2, negative 1/2. Negative root 2 over 2, negative root 2 over 2, negative 1/2, negative root 3 over 2. 5 pi over 6, or 5 pi over 3, this is going to mimic my 60-degree angle. Here my x should be positive, so 1/2, negative root 3 over 2, and y should be negative. Positive root 2 over 2 and a negative 2. And lastly, positive root 2 over root 3 over 2, negative 1/2. Okay, and that is your entire unit circle. Okay, all of the angles in degrees and radians relates to each angle. So for example 4, find the point P, which is x, y, on the unit circle that corresponds to each angle. So 5 pi over 6, all you're simply doing is looking at that angle and talking about the point. So 5 pi over 6, here it is here. It would be negative root 3 over 2, 1/2. Negative 225 degrees. So now I need to rotate in the negative direction, but that is going to be like a coterminal angle to something on my unit circle. So negative 225 would correspond to a positive 135. Right, I'm rotating in this direction, which would give me a point of negative root 2 over 2 and positive root 2 over 2. Negative 7 pi over 3. Well, negative 7 pi over 3, again, I need to rotate positively. And technically this, because this is more than double the 3, so technically this, right? So this is more than double, so this tells me I have to rotate an entire rotation plus a little bit more. So I need to rotate all negative 6 pi over 3, which is negative 2 pi, and then I need to rotate another negative pi over 3 units, which would bring me to this guy here. So what am I looking at? I'm looking at the same as a positive 5 pi over 3, half, negative root 3 over 2. And then lastly, a positive 570. Well, this is definitely more than 360. So if I take away 360 from this, I'm left with an angle of 210. So I'm going to rotate a full rotation. Right? So that's 360. And then I want to go an extra 210 degrees. So that brings me to this position here. And that point would be negative root 3 over 2, comma negative 1/2. Okay? And that is the start unit circle.